Okay, so we're talking about variables on both sides and consecutive integers. So I want everyone to go to your notes that look like this, and we're going to write something on this side. Okay, we're going to write something on this blank side. It's important. So today we're talking about consecutive integers. Consecutive integers. I want you to write some stuff right there. So I want to write down what a consecutive integer is because I'm not really sure. Consecutive integer. So when I say consecutive integer, what do I mean? Does anyone know what I mean when I say consecutive integer? Like, here's an example. 3, 4, and 5. Consecutive just means numbers in a row. Numbers in a row. That's what consecutive means. They follow in order. Okay? So this is 3 consecutive integers. If I define my variables for my 3 consecutive integers, I have 3 variables, first, second, and third. Tyler, I hope that you're writing this down. Those are my 3 variables, first, second, and third. So what is a way for, what variable do you guys want to use? Just someone tell me a variable they want to use. How about X? We'll just start off with X, okay? Go ahead, sharpen it up. So if X represents the number 3, how do I show the next number, the second variable, the second integer using the same variable X? What did I do with this to make it equal 4? What did I do to the number 3 to make it equal 4? I added 1. So that's what my second integer is. What did I do with the first integer to make it equal 5? So that's my third. So this is consecutive integers. And this is how you define your variables. So if I had 4 consecutive integers, what do you think the fourth one would look like? X plus 3. Good job, Hayden. If I had 5 consecutive integers, X plus 4. You guys getting it? You seeing what's happening here? Are we understanding that? Are we going to talk it all today? Give me a nod. I know that you're awake. All right, so those are consecutive integers, but there's more to it than just consecutive integers. I'm awake, but I don't want to be. That's great. Thanks for that. What about consecutive even integers? So what does it mean when I say consecutive even integers? What are even integers? Tyler? Even numbers? They are even numbers. Give me an example. 2, 4, 6. Awesome. So there's 3 consecutive even integers. So I have to define my variables. My first one, my second one, and my third one. Okay. So what's the first term gonna be? Would we use the first term last time? Go ahead, Tyler. X. So if this is X, what did I do with this to make it equal? X plus 2. Good job. And what did I do to this? Go ahead, Tyler. Okay. So if I had 4 integers, what do you think that would be? Go ahead, Tyler. Yep. Do you guys understand how that works? That's for consecutive even integers. Consecutive even integers. Miss Sarah, this is for them. I know that they're like, that's a full packet and these are the partials. I know that they're going to need this. I know that this is horrible to even
Subject.
Yep, and I'm so sorry.
It's just what it is.
So
I'm so curious to know, did you have a conversation with anyone?
I went down there, but they were short staffed. I ended up managing the courtyard during my lunch too.
Nice. Okay.
So, but I did put a bug in his ear. He said he'd make time for me. Okay. So I will keep you in the loop. So that's even numbers. What other kind of numbers do we have?
Uneven.
What are uneven numbers called? Odd. Who said that? Sebastian, good job. So consecutive odd. Okay. Consecutive odd are like 3, 5, and 7. So the first integer we represent with an X. The second integer we represent with, what did I do with this to make it go to that? Tyler. 3 plus what equals 5? I heard someone say it. 2. And my third integer, to go from 3 to 7, what do I add? 3 plus what equals 7? 4. So here's what I want you to notice. I know this is tough. First of all, I'm not even going to lie and say that this is super easy because it's not. This is really tough to wrap your brain around. Here's what I want you to know. I want you to know that consecutive even integers and consecutive odd integers are represented the same way with variables. X, X plus 2, X plus 4, and so on. Even though one says even and the other says odd, they're represented the same way. That's tough, and I get that. But as long as you understand that and you have filled out notes, you can use that on a quiz. Even and odd integers look very different in terms of numbers, but we represent them the same way with variables. Because whether the number is even or odd, they're still 2 digits apart. 2, 4, 6, 8. Two numbers apart. 2 plus 2 is 4. Plus 2 more is 6. 1, 3, 5, 7. 1 plus 2 is 3. 3 plus 2 is 5. Are you guys getting it? Still 2 units apart. Okay? So we're talking about consecutive integers first. Then we're going to solve some more multi-step equations. So if you open up your notes to that first section, the first thing that we talk about is consecutive integers. So I'm going to tell you what's important here. So we're finding three consecutive integers. 3 consecutive integers. So I need to have my first number, my second number, and my third number. I'm going to define my variables. These are my variables, okay? I'm going to just write first, second, and third. So look at your notes that are on the other side of that paper. And what did we say that we always represent the first integer with? Tyler? X. And when we just have consecutive integers, what is the next term? Tyler? X plus 1. Good job. And the third term is? Tyler? X plus 2. Okay. So we have identified our 3 variables. If you can do that, then the rest of it is just solving the equation. It says we have 3 integers whose sum is. What does the word sum mean?
Equal to.
What are we doing to them to make them equal? What operation is it?
Addition.
Addition. Good job. So we're going to add all these integers and they have to equal 15. So let's talk about how we write that. This is our first integer, x, plus our second integer, x plus 1, plus our third integer, x plus 2, all equals 15. Okay. So can we combine like terms? What do you see that looks the same, Jacob? Do you see anything that looks the same that I can group together?
Plus 1 plus 2.
Yeah, plus 1 and plus 2. What is 1 plus 2, Jacob?
3.
3. Okay. What else looks the same?
X and X.
What is x plus x plus x? How many x's is that?
3.
3x. Good job. Equals 15. Now, how are we going to solve this? Everett, what do you want to do to solve this? Yeah. So 3x equals 15 minus 3 is 12. Last step, Daniela, how do I get x all by itself? Divide both sides by 3. So x equals 4. Now we're not done yet. Once we find out that x equals 4, we're not finished. We have to go up and put that into our little expressions here. So if x equals 4, what is the next integer? What is 4 plus 1? Tyler. And if x equals 4, what is the third integer? Or 4 plus 2? Go ahead, Tyler. Good job. Okay. What do we think? How are we feeling about this? It's tough. I mean, it's tedious. There's a lot of little steps, right, that you have to get right to make this work. Okay. Let's look at the next one. How many integers are we talking about? 3. So I'm going to start off with first, second, third. I'm going to do that every single time. That just helps me make sure that I label my variables right. What kind of integers are we talking about? 3 what integers? Consecutive, even. Yeah, these are even. So the first one is always what? X. The first one is always X. But when we use even integers, what is the second term? That's not 2, it's what? X. Look at your notes. Jane, help us out. What's the second term? Yeah, X. What'd you say? We're doing even integers. What are we doing? What is it, Sean? Thank you. X plus 2. And what is the third one? X plus 4. Good job. Okay. Whose sum is, that means we're going to add them up. Jacob told us that, equals 78. So here's my first integer plus my second integer, x plus 2, plus my third integer, x plus 4, equals 78. Now we need to combine like terms. How many x's do I have, Tyler? 3. 3x plus, what is 2 plus 4, Tyler? So 3x plus 6 equals 78. Trying to get the variable all by itself. What do you want to do? You're doing great. What am I going to do? Get the variable all by itself. Yeah, good job, Hayden. I'm going to subtract 6 from both sides. Minus 6, minus 6. 3x equals 72. Divide both sides by 3, and I find out that x equals, go ahead, Tyler.
I thought it was 78.
78, we subtracted 6. Do you see that step? Subtract 6. I find out that x equals 24. But remember, we have to plug that in. So our first number is 24. What's the next term? 24 plus 2 is, Tyler? 26. And 24 plus 4 is, go ahead, Tyler.
28.
Good job. Those are our 3 integers, okay? Again, just nice and easy. It's a little tedious, I know, but we're just going to take it nice and slow, okay? Good. You're doing really good. Okay. Let's look at this next one. How many integers do we have? 4. So off to the side, you have to do first, second, third, and fourth. This is the first time that we've had 4 integers. Okay. Sebastian, what type of integers do we have? Oh, I didn't hear him. I thought he said odd. Yes. Sorry. Consecutive odd. That means our first one is what? And what's the next one? Remember that odd and even are represented the same way. X plus 2. And the third one? It's not 4. It's what? What's the variable term? Help me out, Maddie. What is it? So we're talking about odd integers, which is represented the same way as even. Yes, ma'am. And the next one would be x plus what? Good job. Okay. So this is a little bit different. It doesn't say the sum is blah, blah, blah. What does it say? It says the sum of the smaller 2. I have to add up the smaller 2 integers. So say that again, Sebastian. I'm right here. The sum of the smaller 2. What 2 integers, what 2 variables represent the smaller 2? Go ahead, Tyler. It is. It's x and x plus 2. Good job, sir. Is, we know that is an equal sign. 8 less than, that's that weird subtraction. What happens when I see 8 less than? I'm going to subtract it when? At the end, right? 8 less than, we subtract it at the end. The sum of the larger 2. How do I show the sum of the larger 2? Tyler?
X plus 4 plus X plus 6.
Good job. X plus 4 plus X plus 6. And then I have to do the minus 8. That's what was at the end. Okay. So I'm going to wait a second for everybody to write that down. This one's a really important type of problem. All right. Maddie Stevens, what can I group together on this first side? Is there anything I can group together? The 2 x's become 2x. Good job. 2x plus 2. Everett, on the right side, what can I group together? Just So that's good. Just start with there. 2 variables. So I end up with 2 x's. Okay. Jaden, what else can I group together on the right side? So what is 4 plus 6? Minus 8 is 2. Okay. So when we think about our notes from yesterday, after we get rid of the combining like terms and stuff, we take the variable term from the right and we move it to the left. Everybody do that step. Take the variable term from the right and move it to the left. What happens to my variables? What happens to the variable terms? 2x minus 2x is no x, right? It's 0. So I'm left with this. I'm left with 2 equals 2. I don't have any variables. I don't have anything that says x equals. So let's talk about this. This is special. Okay? So, does 2 equal 2? So this is true, right? So when you solve an equation and you get a number equal to another number, and it's true, like this, 2 equals 2, this means that this equation has many solutions. This has many solutions. And I want you to know what that means. That means that if Jaden gives me any odd number, 5 plus 2 is 7, plus 4 is 9, plus 6 is 11, this will work. What is 5? The sum of the first 2 is 12, and that has to be equal to the sum of the second 2 minus 8. 9 plus 11 is 20, minus 8 is also 12. Do you guys see that? Let's try a different number. Someone else give me an odd number that's a little bit bigger than 5. 13. So the first one would be 13, and then 15, and 17, and 19. Let's see. 13 plus 15 is 28. 17, I'm just trying to show you this. You don't have to write it down. 17 plus 19 is 36. Minus 8 is 28. So it doesn't matter what numbers we use, it will always be true, meaning it has many solutions. All right, that's our last integer question. Let's do a couple of these. Tell me from yesterday, what's the first step? Step number 1, Tyler.
Draw a river.
Draw the river. Step number 2, Maddie. Distribute. Awesome. 5 times x is 5 times negative 2 is negative 10. Pick your head up. We're not taking a nap. Everybody, heads up. Let's go. Okay, now what? What do I do over here? Pick your head up. Come on. Let's go. We're right here. 3x plus 20. What do I do next? Maddie.
Subtract 3x from both sides.
Good job. Subtract 3x from both sides. So 5 minus 3 is 2. So that leaves me 2x minus 10 equals 20. Now what? What do you think, Edward? What do you want to do? Awesome. Add 10 to both sides. Good job, sir. 2x equals 30. Last step, Hayden, we always divide by the number attached to the variable. Divide both sides by. Awesome. And we find out that x equals, thank you, sir. Okay. We're going to skip number 5 and let's go to this one. This is number 6.
Sent me that email and she's not back, so I've got my 3 seniors down
Oh.
here.
Go watch
I'm gonna
them.
just be back and forth.
Okay, I'm so sorry.
No, it's totally fine.
So
I wanted you to know.
this is a special fraction, a special equation. It's called a proportion. And I have to say it like that, otherwise I won't spell it right. Proportion. See, look at that. Don't look at that. Proportion. This is a proportion. What a proportion is when you have an equation set up so that one fraction equals another fraction. Okay? I know it's late. I know we're getting tired. We solve it using cross multiplication.
It's probably not on the right question.
Yes. We solve this using cross multiplication. Okay? You may have learned this. Some teachers call it the butterfly method. We don't call that. I don't call it that, but that's what some teachers call it. So, okay, let's do this. I'm going to cross multiply. Everybody do that. Draw a loop, just like that. That means I'm going to take the bottom number, the 4, and multiply it by the whole numerator, 3x minus 2. And that's equal to, everybody do this. That's equal to -1 times the whole numerator over there, 2 times x plus 3. Close my parenthesis. Close my grouping. So we're just going to do some distribution. So on the left side, 4 times 3x is 12x. Good job. And 4 times -2 is -8. Equals, someone do me a favor. Let's simplify this right here. What is -1 times 2? It is -2. Good job. I'm going to erase that and write it as -2. So when I distribute it, -2 times x is -2x. And -2 times 3, Tyler, is -6. Good job. Okay. We want to take the variable term that's on the right side and move it to the left side. Remember, opposite side, we have to use the opposite operation. What is the opposite of -2x? What do you think, Sebastian? What's the opposite of -2? +2. +2x. So this cancels out. 12 plus 2 is 14. So I have 14x minus 8 equals -6. I have to move that -8. What's the opposite of -8? +8. 14x equals different sign. So I'm going to subtract. 8 take away 2 is, 8 take away 6 is 2. So this is what I have. 14x equals 2. What do I divide both sides by? I divide both sides by the number attached to the variable, 14. So x equals 2 over 14. Can that be reduced? Everett is shaking her head. Yes. Everett, how am I going to reduce that? Divide by 2. That equals 1 over 7. Everett, how did you know that those could be reduced? Because they're both even numbers. Awesome, Everett. Awesome. Okay. All right. We're going to do number 7 and number 8, and then we'll get started on our assignment. Number 7, I'm going to draw my river. That was our first step from yesterday. I'm going to distribute. Are there any parentheses that I need to distribute? No. What about this? Combine like terms. What is 6x minus 2x? Tyler?
4x.
So I have 4x plus 5 on the right equals 4x minus 7 on the left. So Jane, yesterday we said that we were going to take the variable term on the right and subtract it from both sides or move it over, right? Use the opposite operation. So when I subtract 4x from both sides, what happens? The x's go away, and what am I left with? No, I'm not left with 0. I have negative 7 equals what? Yeah. When does negative 7 equal 5? Never. This is never true. So that means that this is no solution. So we put a slash through the equal sign and we say no solution. Because this is never going to happen. So no solution happens when one number does not equal another number and there's no variable term. That's when that happens, okay? When the variable goes away, the variable terms cancel out, and all you have is an untrue statement. Okay, last example, number 8. Someone other than Tyler, walk me through this problem. Sebastian, go. You don't have to do it if you don't want to, sir. Yeah, no, just talk me through it or come back here and do it because we're recording the screen. Oh, draw my river. Got it. And that becomes 12x. Awesome. Keep going, sir. Awesome. Four times negative 2 is negative 8 again. All right. So if I move that variable term away, if I subtract 12x from both sides, what happens? Tyler? They cancel each other out, and I have left what? Negative 8 equals negative 8. Is that true? It is true. Remember what we said happened because our integer problem was like this. Our consecutive integer problem was like this. When we come up with a true statement, what does this mean? It means many solutions or infinitely many solutions. Yes. This has many solutions. Okay. I know that those are tough, guys.